Good evening, everyone. My name is Bhavesh Yadav, Senior Core Committee member of IET VIT. I'm very pleased to see the enthusiasm of the audience and would like to welcome you all to another workshop of Quantum series, Getting Started with ML. Here to guide you with our journey to ML, we have our guest speaker, Mr. Sabyasachi Mukhopadhyay. He's an assistant professor of business analytics at BIMS Kolkata, affiliated to MAKAUT. He's also Kolkata lead of Facebook Developer Circle and is the Google Developers expert in machine learning and Intel Software Innovator. And he was also university course coordinator of BBA and MBA in business analytics at MAKUT. So we are very grateful to have you with us today. The platform is all yours.
Thank you very much, Bhavesh, for the wonderful introduction. So, today we are going to talk about the nitty-gritty of the machine learning. So, basically, our target will be to understand that what is machine learning is, and we will go through some basic demonstration of some important machine learning tools and methodologies. So, today we will explore the coding portion in R. So, basically, I will share a doc file. So what you can do if you are already installed R in your machine, so you can directly reproduce those results, or you may do it later also. As of now, we can understand the coding portion, how we are generating the outcome and all those things. You may visualize it. So what I will do, I will share all those materials, those which will be covered by today, to the organizers. So definitely they will post you all the materials so you can practice at your home as well. So now you see that whenever we are starting about discussing on the machine learning, so basically few questions comes up that what does it require to learn about the machine learning. So I will also write those things in chat box as well, such that all of you can see it. But just to give you some idea that whenever we are starting your journey, you may be the student of the management nowadays. In management, be student from the business analytics background, they are also learning machine learning. You may be the students of the engineering background, mostly the students from the computer science, electronics communication engineering students are there. There may be the students from the BSc background in computer science as well. And in science background, some students from the mathematics, physics, chemistry also, they are showing their interest in machine learning. So the thing is that first of all, you require to know very basics of the statistics and probability. Okay, for example, descriptive statistics, inferential statistics. Along with that, the basic knowledge on the probability, Bayesian theorem, because you know the algorithms like the naive Bayes classifier and all those things are completely based on the Bayesian probability. And along with that, all of you would require to know the basics of the linear algebra, how to calculate the eigenvalue, eigenvectors, because those are the important part of the, for example, the methods like the principal component analysis, singular value decomposition, because it's not only about to run the code correctly, but to interpret the result is very, very important. So you require to know them. And along with that, whatever you require to know basically for the for your understanding purpose, that is the, for example, if you are talking about the coding portion, R and Python, which are the very open source software, at least any of those languages you require to know R or Python. If you know the both, that would be fine. And for the visualization purpose, Power BI or Tableau, that would be good enough, because in Indian scenario, if you know Power BI or Tableau, those are the basic necessity of getting the 6-digit salary job in the industry as well. So let me post whatever I have said so far in a nutshell. I may let me write it in the comment box. So I would request organizers to share with all of you. Okay. So let me, first of all, I talked about the linear algebra. Okay. So we require to know the basics of the linear algebra. Okay. Along with the linear algebra, probability and statistics. Okay. Along with the probability and statistics, we also require to know about the some languages as well, R, Python, coding. Also, we require to know about the. I think this you can see those comments in the chat box with whatever I am sharing there. So along with that, also for the visualization purpose, we require to know Power BI and Tableau. Advanced Excel, if you are a student from the management background, you can go through the Advanced Excel as well. That is very effective tool for generating the plots and doing some awesome stuff related to statistics. Okay. And one more thing, if you are a student of the computer science, IT or DC, all of you in your B.Tech curriculum, you might be going through one particular important subject, that is your basically data structure and algorithm. That is very, very important because you see, from those who have gone through the data structure and algorithm, you have the basic idea that the time complexity or the space complexity. I am just giving you one particular simple example. Okay, so all of you know that if you have the matrix has a n by n matrix. If there is a n by n matrix, now what will happen that if you are traversing row by row, what will be the order of complexity for n by n matrix? It will be order of n square. Okay, because you have to go through by the nested for loop, and it will increase the order of complexity. So now, if you want to, for example, what will be the way to reduce the time complexity? So basically what happens that from our basic knowledge, if you are learning about the those who are already the part of the data analysis, they may know that whenever you unfold the data, you can extract the more information from the data. It can be horizontal unfolding or vertical unfolding. So this type of the method, in the terms of the linear algebra, we call it vectorization. So if you do the vectorization, what will happen that, for example, even your first row, if you have ABC, and second row, if it is DEF, if you are unfolding it column wise or the row wise, so what will be now after vectorization? So it will be A, B, C, D, E, F in this way, either row wise or column wise. So your order of complexity is reduced from the order of n square to order of n. So this is the way we can reduce the time complexity, because you see nowadays we are going for the lightweight device processing. Okay, earlier days it was all about the taking the help of the CPU, then GPU came. We were used to take up the GPU, virtual GPU for the cloud concept. Now it is all about to reduce the load from the cloud. So what we are doing, we are taking some light processor devices like smartphone. For example, it can be the gateway as well, which is the example of the network gateway is will be the good example of the fog computing. So using the smartphone for the computation purpose will be the good example of the edge computing. So we are doing the lightweight processing of the coding. So these type of the things only can be possible if you can reduce the time complexity. Now these are all about the things which we require to know to learn machine learning and all those things. Now let me tell you basic discuss with the basic background of the machine learning, because you see this is not a new concept. From the 1940s, people started to explore with the neural networks, and then it was all about the mimicking human activity. Okay, like the way human brain works, it was all about mimicking that activity. But what happened that with as the time passes, people realize that the computers can be the regular part of the official work. We can store data in the computer. Okay, we can process data there. So basically from end of the 1950s in the developed countries and end of the 1960s in the developed countries, people realize the need of the computers, okay, as a part of the computer. And lot of institutes, for example, in our India, the first computer science program has started by IIT Kanpur in 1963. If I am not wrong, it was in 1963, and then gradually all the institutes got interested to launch the computer science. And then it was all about dealing with the relational databases. We used to store the data in a structured manner. So few packages, software packages in early 80s people launched, for example, then SAS, SPSS, those softwares were there. People gradually started to shift from the procedure oriented language to object oriented languages. Okay, so from C++ to Java, which is a pure object oriented language, people gradually started to go there. But when the object orientation started in 1990s, actually Linux Foundation played a very, very important role. You may have seen a lot of Linux Foundation chapters in your institute, maybe, or if you see a lot of NITs are also having Linux Foundation chapters. So basically what they are doing, they are basically the prime enabler of this open source concept. So like the R or the Weka, these are the blessings of this type of the GNU free project, blessings of the open source era. And then Python also. Okay, so in 1990s, when the Ross Yahak and Robert Gentleman, okay, they basically launched, got the concept of the R. They basically advanced the S programming language, and as their name starts with R, Ross Yahak and Robert Gentleman. So according to their name, the program has been named as the R programming. And then John Campbell did the icing on the cake. And from 2001, people started to explore it. So it is freely available. If you search in, those who already have installed it, it's fine. If you don't have installed it, you can search in the internet R programming language. You will get one particular link from the CRAN website. You can download it from there also. So you, as per the OS options. Okay, it can be Windows, it can be Mac, it can be Linux. You can download it. So you can explore it as well. If you are using Python, you can explore, you can download it, or you can explore the Colab. Okay, Google Colab, you can run the code there. So these are the coding part. And then whenever, like, let me back to the machine learning discussion. So it was all about the relational databases when people started to explore, because in those era the data volume is not so much. Okay, so we but what happened that when the 90s era started, I already mentioned that the open source era started. So basically what happened that from 1994 we started to explore with the world wide web, www. Then what happened that we started to using email on a daily basis, and in from 2000 era, if you see the web 1.2, at the end of the web 1.2, where the people are explored, we started to explore with the social media. And web 2.0, if you see, it was all about the dominance of the social media, where if you see, for example, Facebook, LinkedIn, those things came up. So whenever you are typing some text, you are posting some images, or you are posting some videos, we started to generate a lot of unstructured data. Okay, so what is happening that whenever you are logging in, you're logging in your activity time and log out time, these are being stored in the tabular format. Okay, so this is the structured part. And whenever you are posting some images, videos, okay, these are the unstructured part. So altogether, you are basically generating the semi-structured data. So humongous amount of the semi-structured data has been generated during the era of Web 2.0. And due to that reason, our digital wall started to become double day by day. Okay, and nowadays it has the exponential growth. So that's the reason you see, Sarah, there is so much demand of the MongoDB Cassandra for the, you see, for the data, those who are the data engineer, they basically become interested on that, because earlier it was all about the SQL, but it's now MongoDB Cassandra. People are already talking about it. People are talking about big data as well, and three V's of the property of the big data: volume, variety, and the velocity. Okay, so if you see, these are the basically, it's not only about the computational part, but you will also require some processor power. Hardware development is also required, because we already maybe aware of the some terminologies related to machine learning, some method, for example, decision tree, random forest, KNN algorithm, k-means clustering, or the general clustering model, hierarchical clustering, SVM. These are the very popular machine learning methods. Now, what is happening that when SVM, for example, support vector machine came up, it was very much popular in 1997, in early 2000. It was very much popular, because when you have the data in order of 10 to the power till 10 to the power 4, machine learning algorithms are quite capable to process them to give you the high accuracy. But from, if you have the data in order of 10 to the power 5, like I was mentioning, that due to the generation of the semi-structured data so much, nowadays I mean, high performance computing is an integral part, and you know that data in order of 10 to the power 5, the machine learning performance saturates. So there are concepts like the transfer function. For example, if you are using sigmoid function or the tan hyperbolic function, these are the very popular activation function as a part of the machine learning algorithms. These are not the performance-wise scalable. Okay, but for example, I want to also give you one example that before the GPU era came up in 2012, NVIDIA launched GPU. Okay, in 2015, Google came up with TPU. So then it was become quite easier to process the high volume of data, but earlier it was not easy case. So in 1988, when the deep learning mathematics has been developed, and the Ian LeCun came up with the LeNet, okay, the first step in the deep learning, LeNet, one of the deep learning architecture, then it was not so much powerful, because they have used activation function like sigmoid function. So these are quite analogous to machine learning performances. And even the support vector machine was so powerful, they beat the performances of the LeNet. But from the 2012, gradually the AlexNet, which was another deep learning architecture, from that the deep learning era started, because in that period of time you have the high processor support, like NVIDIA came up with the GPUs. Okay, and from 2015 onwards you have the support of the TPU. Okay, and along with that, the another important activation function, which is performance is scalable. Okay, that is came up with the TPU basic, sorry, that is a ReLU function. Okay, so ReLU actually made the system so much robust that it became the performance wise scalable. Okay, because you know, the more you will build the training database strength, the more you will get the accuracy. That is the common concepts of the machine learning. Now, what happens that performance-wise scalability we are talking about, that if you have the higher order of data, 10 to the power 5 onwards, then it is not possible for the machine learning to perform the scale, that utmost scalability, to produce the utmost scalability for the optimum classification purpose. And that is the shortcomings of the machine learning algorithms, okay, because they are using the activation functions like ReLU or the tan hyperbolic, which is, if you see, after a certain portion of time, if you see, the graph is saturated. But you require to produce some continuous performance, continuous scalability, which can, for example, a human being, if you see, it is not a possible for a normal human being to work for 24 by 7. Okay, you may work till 12 hours, 14 hours, 16 hours, then your performance will be saturated. So the performance curve is like, our performance curve is quite analogous to the tan hyperbolic or the sigmoid. But whenever you are considering the concepts like the superhuman activity, okay, so then what will happen? Then if there is no tiredness for the robots, for example, if you say for the superhuman activity, so what will happen? Their performance curve will be something like ReLU, okay, ramp like function. It is continuous scalability will be there. So that was the basic background. So although the nowadays this is the era of the deep learning, so many things are coming up, interesting things are coming up. We are gradually proceeding from the weak AI to moderate AI. We are dreaming of strong AI. Okay, so in that particular, with that particular background, I just want to give you certain idea on the few easy machine learning methods. Okay, how you can process data, how you can start with the machine learning, because this is the very basic discussions. Okay, with that background I want to start. And I also want to highlight one thing: if I get the opportunity next time, I will discuss about the quantum machine learning, because in that period of time I would believe that all of you will have some basic idea on the machine learning as well after today's session. So on that day it will be the perfect setup for discussing the quantum machine learning as well. Because you see, like I was mentioning, that the way the digital world is getting double, our physical processors will gradually become obsolete to process the data by 2035, our existing physical processors. So you will require the quantum processors to process your data. So what will happen, that our world, with the help of the entanglement property or superposition property, quantum world will do the wonder in upcoming days. And you may have seen that the lot of interesting news related to the investment of the lot of top level countries, United States, China, even our government of India has also invested a lot of money to encourage the quantum research. Okay, and especially if you see the quantum AI angle, lot of new thought process are coming up. Already quantum PCA, quantum support vector machine, they have done in a very satisfactory job, because quantum algorithms are performing exponentially faster than the classical algorithm. Okay, so a lot of promising things are gradually coming up. People are also dreaming of the quantum deep learning as well. So in upcoming era, okay, it will be very much interesting to know. That's the reason Google came up with the TensorFlow Quantum to support the quantum machine learning activities. Okay, you may have heard about the IBM quantum experiences, where you can draw the quantum circuits and you can see the amazing results out of it. So to learn quantum machine learning, what are the things will be required? Along with whatever I have mentioned earlier, okay, for the quantum machine learning, you have to additionally know about the quantum computation as a basics. Okay, if you know the quantum computation as a basics, then it will be easier for you to know the quantum machine learning as well. So I am mentioning the requirement of the QML as well in the chat box section. All of you will be able to visualize it in your screen. Okay. So QML purpose, along with the above mentioned methods, you require to know about the basics of quantum computation. Okay, so I already have posted the comment. I would request the organizers to share with all of you. Already it is posted now. I believe that you can see in your screen that earlier mentions, all those things will be there. Only you require to know the extra thing, that is the quantum computation. So once you know the quantum computation, you will be able to get gradually get started with the QML part as well. Okay, so these are the very basics which you require to know. You require to learn about the journeys, what are the career opportunities are coming up in front of you, because the lot of nowadays the world is data driven world, because you are not storing data with pen and paper, you are storing data with cloud. And as I mentioned, to reduce the load from the cloud, we are going with edge computing for computing type of concepts. Okay, so it's all about the how you can utilize the data, how you can process the data smartly. Okay, then you can get the benefit of the data processing. Okay, so let me start with the very interesting discussions with the I mean, from the very beginning. It's a very easy and useful process that we will start with the KNN algorithm. Now, to start, before starting with the KNN algorithm, let me tell you that with machine learning, whenever we talk about the machine learning algorithms, you may have the data, either leveling data or may have don't have the level data. So if you have the level data, that means, for example, if you have some images, okay, you have 10 images. Okay, there are some images of cats and dogs. Okay, so what will happen, that there may be some labeling may be there, that these images are cats, these images are dogs. So what will happen, that you will build a training data set. Okay, and then some unknown sample will be given there. You have to predict that whether it is cat or dog. Okay, but remember that the way you will learn, you will make the algorithm learn about the labeling. Okay, this process is called the supervised learning. Okay, because you are giving some labeling data, and the unknown sample which you will put, that should be either cat or dog, such that your system has been trained in such a way that it only can recognize the cat or dog images. So for example, you are putting some unknown samples, so you want to check the efficacy of your system. So it may happen that your system may predict it correctly as cat, it may not be able to predict correctly. Okay, so depending on that, you will calculate the accuracy of the system. So this is all about the way machine learning works. So if you have the level data sets, so it will be the supervised learning. If you don't have the level data set, then it will be unsupervised learning. In those cases, so it goes with the basically clustering concepts. It can be k-means clustering, it can be hierarchical clustering, that type of concept. We may go with that. There can be the semi-supervised learning as well, as some portion is level data, some portion is unlabeled. So semi-supervised approach may be there. Also, nowadays it is one of the concept is getting very much popular, that is a reinforcement learning, where basically interacting agent will interact with the environment and they will learn it. Okay, so from the experiences, if they are able to predict execute the task correctly, they will be rewarded, other it will be punished. So in this way, reinforcement learning works, and in those cases you don't require to data labeling. That is the benefit of the reinforcement learning, because it is continuously interacting with the system and it is learning. Okay,
Excuse me, sir.
so now,
Sorry to cut you
yes,
in between.
sure.
Uh, so some of the viewers are unable to see your screen. Could you please reshare it
No, I have
again?
not shared the screen. I will share the screen. I am just
Okay.
talking about the background. Okay.
Okay.
So now I
Thank
will
you, sir.
share the screen.
Thank you, sir.
Oh, most welcome. So I have not shared the screen so far. I am just talking about the basic background, basic concepts, whatever you require to learn for the machine learning or deep learning or the quantum machine learning, and just give you some idea related to the what is supervised learning, unsupervised learning, and semi-supervised learning, as well as reinforcement learning. Now I will share the screen, because we will start to explore on the KNN algorithm. So first we will talk about the KNN algorithm. So there are a list of the commonly, if you see, there are a list of the very commonly used some machine learning algorithms. You can see. So linear regression, logistic regression, because you see you can either do the regression stuff or classification stuff. Both the way you can explore the machine learning algorithms. So few popular methodologies, if you see, like we are starting from the linear regression, logistic regression, decision tree, SVM, naive-based, KNN, k-means, random forest, all those things are there. We will start with the very basic and very simple machine learning algorithm, that is the KNN algorithm, which is the K nearest neighborhood algorithm. Okay, that we will explore with the R programming. So those who have installed R, that is fine. If you don't have installed R, so don't worry, you just process you just follow the process. Okay, code Okay, all those codes are executable, don't worry. All the how you can run those codes and what will be the outcome, everything has been marked there in the document. Okay, so in the KNN algorithm, okay, what we'll do, you basically will have the some level samples will be there. Okay, so how will it work? Now we have to see. So when do we use the KNN algorithm? That would be the first utmost things which you require to know. That it can be used for the both the cases, for the classification as well as the regression. In both the cases, you can utilize it. So what will be the very basic important steps related to it? So the important aspects, if you see, first of all, the why the KNN is so much popular. First of all, is to interpret the output, okay, calculation time, okay. Another one is the predictive power, okay. So this is the comparative purpose of the how you can see this superior in comparison with the other algorithms. Now, how does the KNN algorithm work, which we will require to know? So basically, you may have that red circles and the green square. If you see, for example, in the following figure, if you have the red circles and green square, now you may have to find that if the blue star, how will classify this particular blue star? So blue star in abbreviated form, it is written as the BS. Red circle in abbreviated form, it is written as the RC, and the green square in abbreviated form, it is written as the GS. Okay, so now what we'll have to see, that we have to find the K in the KNN algorithm. Okay, is the nearest neighborhood you wish to get the vote from. So if you want to put the K value is 3, okay, now we will try to make BS as the center, okay, and we'll try to see that in which category BS will belong to, okay, or the blue star will belong to. Now, if you see, for example, if you are taking the three nearest neighborhood with respect to K equals to 3, then it is quite understandable that with respect to these three blue circles, okay, this blue star should belong to this particular group, which is the red circle group. It is quite unlikely that particular blue star will belong to this green square group, okay, with respect to K equals to 3, because these three closest point to BS are all RC. If you see the three closest point, three nearest neighborhood point, okay, with respect to this blue star, all are the red circle. That's the reason we will make conclusion that this blue star will belong to the red circle category. So this is how you can finalize the whatever the neighborhood point you will consider, and according to the neighborhood point, you will make the classification that for a particular unknown point, which category it will belong to. Like here we have done it for a blue star. Okay, we have tried to figure out that whether it belongs to the red circle or the green square. Okay, now how do you choose the factor K? Okay, so that thing we have to understand. So what will influence it? So basically we what we will see that the we will start from K equals to 1, okay, K equals to 3. You can see for the different categories how the boundaries are changing. Okay, for K equals to 1, K equals to 3, K equals to 5, K equals to 7, for the different values, if you see carefully, that the boundaries will gradually become smoother with the increasing value of K. Okay, so with the increasing K, as the K is increasing to infinity, what will happen that it finally becomes the all the blues and all the red, depending on the total majority. Okay, it will be easily able to segregate it. So training error and the validation error you require to understand. Now, few concepts which come up, that if it may happen that your algorithm is performing very well on the training dataset, but they are miserably failed on the validation dataset. So that means that your system is suffering from the overfitting. Overfitting means it will be basically your high variance will be there. So you have to reduce the high variance. So you can increase the training time, okay, or you can make the model a little bit look simpler, such that you can avoid the overfitting. So regularization is one of those ways how you can avoid the overfitting. So we have to see, for example, this is the case. If you see that you have the different k values, you are starting from the K equals to 1, okay, and as you can see the error rate K equals to 1, okay, always will be 0 for the training sample. This is because this is the closest point to any training data, but the prediction will be always correct with K equals to 1. But what would happen, okay, that whenever you are gradually increasing the value for K equals to 1, okay, so this type of curve you will be able to see for the training data. Now for the validation data, what will happen? For the validation error curve, okay, you see that for K equals to 1, Okay, we are overfitting the boundaries. Like I was mentioning, that system is doing very well for the training dataset, but miserably failing for the validation dataset, because validation error is greater than the training error. So overfitting will happen, because k equals to 1 in each cases, it will be the nearest neighborhood. Your accuracy for the training case will be 100%, but the validation error will be in peak. Okay, it is miserably failing during the validation period. Okay, now what will happen, that gradually once you are increasing the value with k and you are trying out, gradually the validation error will start to reduce, and this is the minimum point. Okay, that you have to pick up for the optimum value of k, because you have to stop somewhere na. You may take that, I can take one neighborhood point, three neighborhood point, five nearest neighborhood point, seven nearest neighborhood point, but I have to stop somewhere. But what would be that optimum result where your validation error will be less? Okay, so this validation error will be less. You can see around it is k equals to 10 or something like that. Again, you see the validation error started increasing. So you have to pick up that minimum value. Okay, so to get the optimum value of k, you can segregate the training and validation from the initial data point or the data set, and now plot the validation curve to get the optimum value of the k, like we have got it here. Okay, so this is the way you can generate the optimum get the optimum value of k. So how to select the appropriate k value? So choosing the number of the nearest neighborhoods or determining the value of k plays a very, very significant role while determining the efficacy of the model. So thus the selection of k will determine that how well the value can be utilized to generate the results of KNN algorithm. A large k value has the benefit, okay, which can include the reduce the variances due to the noisy data. Okay, so let us explore one of the particular example of the KNN algorithm. This is one will be the mathematical algorithm, a mathematical example. Okay, because you see, whenever you are trying to learn certain algorithms, okay, so here we will not be able to cover up everything because of the shortage of time, but while you are studying, make sure that after you learn about the theoretical basics, you try to solve a mathematical problem with that particular algorithm, whether it can be naive based algorithm or it can be knn, k-means clustering, whatever the algorithm. Maybe just try to solve one numerical problem, then you start coding part. So what will happen, you will have the 360 view in front of you. Okay, so we have just made a little bit of theoretical overview. We learned about the knn algorithm, that how depending on the k nearest neighborhoods the classification can be done. Okay, or how we can find the optimum value of k. Okay, where we will find the minimum value of the validation error, that would be the optimum value of k, that we have learned. Now we will try to solve one mathematical problem, very simple mathematical problem. So you see the ingredients are given there. Okay, two features we will try to find out. Okay, so 10 drinking items will be I mean, on the basis of you will basically try to scale them up between 1 to 10 on the basis of these two parameters, whether it is the sweetness or the fizziness. Okay, the type of the drinks are mentioned there. For example, energy booster, it can be health drinks, it can be cold drinks, it can be hard drinks. Okay, and sweetness and fizziness are mentioned there. So sweetness is understandable, fizziness means a lot of bubble will be there. Okay, so on the basis of the presence of the bubble, you are trying to rate it 1 to 10. Okay, so sweetness will be the basically it will determine the perception of the sugar content in that particular item, and the fizziness will give you the presence of bubble in the drink due to the carbon dioxide content in the drink. Okay, all of you know that. Now we will try to figure out that which type of drink it is, whether it is the energy booster or the health drink or the cold drink or the hard drink. This is the given database is there. We will put some unknown sample and we will try to figure out that which class it particularly belongs to. Now, for example, if this is basically your structure, the sweetness and the fizziness is there. Okay, and now you want to find out that if we are putting some unknown samples like maza, okay, now in which class maza will belong to, that we will try to figure out. Okay, whether it will be the part of the health drinks or the energy drinks or the cold drinks or the hard drinks, that we will try to figure out. Okay, so now if this is the scenario, so how we can do that, so how we can compute the k nearest neighborhood for it. So let us calculate the distance. Now let me tell you that there are a lot of popular distance algorithms are available. Okay, there are Euclidean distance, Manhattan distance, okay, Chebyshev distance. So there are very good amount of the distance algorithms are there for calculating the distance. But what we will do, we will follow the calculation on the basis of the Euclidean distance, because this is a very simpler purpose for understanding, and it is a very easy and robust. Okay, so we will calculate the distance on the basis of the Euclidean distance algorithm. So basically, you know the formula of the Euclidean distance. If this is the point P1, if it has the coordinate x1, y1, for this particular point P2, it has the coordinate x2, y2. And if the Euclidean distance is small d, you know the formula. How can we calculate that? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now you see, we will define the coordinate for the maja. Okay, the coordinate of the maja is, for example, 8 comma 2, and if the bhadra is 2 comma 1, then what will be the distance between them? The distance will be 6.08. So in this way, the other coordinate informations will be given there. So if you have those informations, you will find the distance to maja. For the Monster 6.08, for active it is 1.41, which is a health drink. For Pepsi it is cold drink 7.21. For vodka it is the hard drinks, the distance is 6.08. So we have found out these distances. Now from the k nearest neighborhood, if we consider three nearest neighborhood point, okay, 6.01, 1.41, 6.08, which one is the nearest distance? The nearest distance is, if you find that k equals to 1, it will be active. Okay, that means the maja will be considered under the nearest neighborhood of the health drinks. Okay, and if you consider with the three points, okay, what are the three nearest neighborhood points? 1.41 active, Monster 6.08, vodka will be 6.08. We will omit Pepsi because it is 7.21. So with respect to that, we will find that active stands for nearest to maza. So in which class maza will belong to? It will belong to health drinks 1.41, because this is the shortest distance or the nearest distance. So this is how you can solve the mathematical problem, okay, by calculating the the nearest neighborhood point. So you can either consider k equals to 1, okay, k equals to 3, k equals to 5 in this way. So here we have the 4 points, okay, 4 category types. And whenever you are putting maja to find the which will be the shortest distance, k nearest neighborhood. So k equals to 1, we also have seen active. K equals to 3, also have find it ACTIV or active. That is the category of the health drinks. So we are considering that maja will come under the health drinks. So in this way, you can do the numerical problems related to k means k nearest neighborhood algorithm or kn. So what will be the pros and cons of this type of the algorithm? So this type of algorithm is quite highly unbiased in nature, and you don't have the no prior assumption of underlying data. So that means it will be very simple and effective in nature, and it will be easier to implement, and that's the reason it has gone so much popularity in the industry. Con side, definitely there is no algorithm is perfect. Okay, so there are some negative side is also there. This is a very weak learner. I mean very lazy learner, better to say, because it takes time. Training data takes time to learn the features of the from the data. Okay, so that's the reason you can consider it as the negative side because of the part of the lazy learner, but it is a very very effective algorithm. Now, if you see the general steps of exploring the KNN algorithm, so first up will be the loading of the data. Then what you have to do, you have to initialize the K value. Then if you see the pseudocode, then what you will do for getting the predicted class, we will start right from the iteration from K equals to 1 of the total data point. So calculate the distance between the test data and each row of the training data. Here, basically, we will try to use with the Euclidean distance for your understanding purpose, but there are other distances as well: Chebyshev cosine, Manhattan distance, Moholy-Nagy distance. So those are the very popular distance algorithm as well. Then what you can do, you can sort the calculated distances in the ascending order based on their distance values, okay, and get the k top rows from the sorted arrays and the most frequent class of the rows, and finally return the predictive class. Now, what we will do, we will cover up the basic theory. We have covered up the mathematical numerical problem to solve the KNN algorithm. Now, what we'll do, we will try to explore them, KNN classifier in R programming. Now, those who are accustomed with R, those who are new to R, let me tell you that the in R programming, what happens that there are a lot of benefits because it has the extensive support of the related to the statistical processing of the data, and due to that, what happens that it has a lot of inbuilt data support, data processing support. You don't have to upload data externally. So, like in case of the Python, we may have to always take some third-party extensions. It can be NumPy, SciPy, SymPy. You have to upload data externally. But in R, it has the benefit of the R that it has a lot of extensive data processing support, and it has some inbuilt data set as well, which you may explore while analyzing the data. Sorry. So in case of the K nearest neighborhood algorithm, we will start processing with the iris dataset. So now iris dataset, it has the 50 samples with the 3 species. So it can be iris setosa, iris virginica, iris versicolor. So we have the altogether 150 samples are there. Okay, and what are the features? It can be sepal length, sepal width, petal length, petal width. 4 features are there. Okay, now we will try to figure out that which type of category it belongs to. Now what you'll do, you see this is the coding portion. Those who have installed R, they may write these 2 lines of code. Those who don't have installed R, don't worry, I will share these materials with your organizers, so you will be able to run this. All this code will be executable because I myself have tested that, and during my classes, during my talks, okay, I always deliver this material, so everybody has been able to run it successfully, so nothing to worry about it. So as this is the inbuilt dataset, what you have to do, you have to just write data function over iris. You may want to try out the structure of the data. Now, what will be the structure of the data? That you can explore it in R with the str function. So if you apply str function over iris dataset, you will be able to see this following 150 observations with 5 variables. That means there are 5 columns and 150 observations, means 50 iris setosa, 50 iris virginica, and 50 iris versicolor. So there will be altogether 150 observations. So that will be stored in row wise. And what are the 5 columns or 5 variables? 4 features: sepal length, sepal width, petal width, and one is the species. Now you see the species means in which particular species the iris data set belong to. It can be versicolor, setosa, or virginica. Now you don't have to use this particular column because as we want to predict the species from here, so it may add up the biasness in the system. So what we'll do during our calculation, we will omit this 5th column from our analysis, and then we will predict it in order to remove the biasness from the system. So let us see how we can do that. So once you do this basics processing, okay, we have to install certain packages to explore KNN classifier on inbuilt iris dataset. So like install.packages E1071 or install.packages CA tools, install.packages class. Once you have done the installing of these packages, okay, then what you can do, you can load those packages using the library function. Library E1071, library CA tools, library class. So once you have done the installation of all those packages, what you have to do, you have to load these packages, okay? So once you have done the loading of the packages, then what you have to do, you have to split the data. Now you see that in general machine learning concept, that whenever you are doing the splitting of the data, 70 to 80% of the whole data set will be used for the training purpose, and rest of the 20 to 30% of the data will be used for the testing purpose. So during the split, you have to mention the ratio of this splitting of the data. So in the next step, whenever you are splitting the data into training and the testing data, what you will do, you will simply use this sample.split function and you will store the result on the split. So iris will be the first argument, okay, the data set name 0.7, because we are using 70% of the data for the training purpose, rest of this for the validation and testing purpose. So that's the reason split. So make sure that R, even you are coding in R or languages like Python, these both are the highly case sensitive languages. So make sure that you are not making mistake while, so make sure that you are writing it correctly. Okay, so then what you will do, you will use the subset function because you have splitted the data, so you will access those split portion with this subset function. So first argument will be the iris data, and the second argument split equals to true for the training, which you will store under the train underscore class, and then test underscore class. Whenever you will store, you will use the subset function. First argument will be the iris data, next split will be false. Okay, now what you will do, once you have done the splitting of the data, training and testing data successfully, now feature scaling will be there. So how will you do this feature scaling? During this feature scaling, remember that we will drop one particular column, species column. We will use the first 4 column: sepal length, sepal width, petal length, petal width. 5th column, species column, will be dropped out because we want to predict the species. That's the reason. If that particular column present there, then what will happen? It will add the biasness in the system. So we will remove that particular column called species. So what here? How we will scale it now? So we'll use the scale function. Train underscore class CL will be the function name. Left side of the comma will be the row of the data, because we are using all the 150 rows. Okay, 50 for the iris virginica, for the iris setosa another 50, and iris versicolor for another 50. So we are not omitting any row. So left side of the comma there will be, that's the reason we don't have to mention anything. But right side of the comma, you have to write 1:4. That means you are using first to fourth column. Now remember that R is always one indexing language. It will always start, whenever you are doing indexing, it will always start from 1. 1, 2, 3, 4. In this way, you will calculate it. But Python, whenever you are coding in Python, remember that Python is a zero indexing language. So whenever you are coding in Python, it will start from zero indexing, 0, 1, 2, 3, 4 in this way. Okay. So that's the reason, as we want to pick up the first four columns, we are writing 1:4. Okay. Fifth column, we are omitting. In a similar way, whenever we are picking up the test data set, okay, scale function will be there. Test underscore class, where you are basically accessing the indexing values. Left side of the comma, we will not do anything, write anything, because we are considering all the 150 rows altogether. Okay, what we are doing, we are basically writing, we are picking up these four columns, first four columns, so 1:4. That's the reason we have written as 1:4. We are not considering the species column. So it is stored under the test underscore scale. Now what will to train the dataset? So what we'll do, we'll apply the knn function over it. So in the first argument, train equals to train underscore scale. In the second argument, test equals to test underscore scale. And class equals to train underscore class. Here you are basically considering the species column. So whenever you want to access the species column, what you have to do? You have to apply this dollar sign, okay, of a given dataset to access the column. Now we are checking out for k equals to 1, because you know that we'll start from k equals to 1 and then we'll try out with different number of k's and we will find out the optimum result. So for k equals to 1, if you print out the classifier underscore knn, so this classification will be shown setosa. Some cases it has been predicted as virginica, it has been predicted as the versicolor as per the given classes there. Okay, now what you will do, you will form the confusion matrix. So how can you form the confusion matrix? So we will use the table function. Now you see that whenever you want to put something in a tabular format, okay, the formation can be done with the help of, in R, we'll always use the table function. So now in table function, what will be the first argument? Test underscore class dollar species, because we are accessing the species column. So that can be done using this dollar sign, comma, classifier underscore kn. Then you print CM. CM stands for confusion matrix. So if you see the system performance here, 20 setosa has been correct. If you, this is the output, you see this red labeling always follow whenever you will produce these results in whenever practicing at home, or whenever those who are writing the code now, this color labeled has been given their code. The code is under that. Whenever you want to check the output, that you can check under this output labeling. So once the output you are getting, 20 setosa has been predicted setosa correctly. Okay, among the 20 versicolor, 18 has been predicted correctly as versicolor. 2 has been predicted wrongly as virginica. Out of the 20 virginica, you see, 2 has been predicted wrongly as versicolors. 18 has been predicted correctly as the virginica. Okay. Now what you can do, you can simply calculate the sample error. So how can you do that? So use the mean function over classifier underscore knn, which is not equals to test class dollar sign species. So this is being stored under the misclassification error. Okay. So whenever you want to try the predict the accuracy, so that will be 1 minus misclassification error. So print paste accuracy equals to 1 minus misclassification error. Now print paste means it will give you the concatenated outcome. So that means it will print like the way you want to print it. Accuracy equals to certain percentage. So like the way it has printed, accuracy equals to 0.93333 something. So that means at k equals to 1, you are generating the output 93.33%. Okay. Now, in a similar fashion, you can do it for the k equals to 3 as well. So how can you do that for k equals to 3? So in a similar way, you will write the code. Every step will remain same. Only you will change the value of k. In the first example, we have done it with k equals to 1. In the second case, you will do it for k equals to 3. And then you will store the result in misclassification error. Okay. Same steps will be repeated. There is, we are not doing anything new. Only we are changing the value of k. So once you change the value of k for k equals to 3, you are also getting the accuracy equals to 0.9333 something. That means 93.33% for k equals to 3 as well. Now you want to check for k equals to 5. You are repeating the same steps, only you are changing the value. So we have done it, only edit the value of k equals to 5. And so once you have changed it, you are getting the output accuracy equals to 0.95. That means the model has achieved 95% accuracy. That means the accuracy has increased. For k equals to 1 or k equals to 3, we got the accuracy 93.33%. But for k equals to 5, we got it 95%. Okay, so that means it is giving you the better result than k equals to 1 and 3. Let us try out with the k equals to 7. Now you know that in any programming language, when you use the hash sign and then you write something, that means it comes under the comment. Okay, it will not be executed under the code. So k equals to 7, we have added the hash sign. So now we are trying out for the k equals to 7. So all the coding steps will remain same, only we will put the value k equals to 7. Okay. Now if you are printing the output, you will get 96.666%. That means result again has improved than what the outcome we got from the k equals to 135. That means your validation error is reducing gradually with the increment value of k, like we have learned earlier. Now in this way, we will try out different values. I am going exactly trying out with k equals to 15. Now at k equals to 15, I am getting much more improved value. That is 98.33% than what we achieved for k equals to 1357. For k equals to 16 again. So all the code structure remains same. Only the k value will be updated. K equals to 16. You see, output is 98.33. Okay, k equals to 17 you may try out 98.33. K equals to 18 you may try out 98.33. K equals to 19 if you check, the value is dropping here 96.666. Again the value is dropping. That means the validation error is increasing. So the validation error minima has been achieved with the value between the range of k equals to 15 to 18. In both the cases, all the four cases, sorry, k equals to 15, 16, 17, 18, you got the accuracy 98.33%. So that's the reason you can consider any of those values. Okay, k equals to 15, 16, 17 or 18. In all the cases, you will get the best accuracy. So you may take the lowest value like k equals to 15 as well to consider that which will give you the best output of the system accuracy, that is 98.33%. So whatever we have learned from the KNN algorithm, that it is one of the most simplest classification algorithm. Okay, although it takes some time during the learning of the features during the training period, but it is a very robust algorithm. Okay, and that's the reason it is widely used in the industry. Okay, so that's we have discussed for the KNN algorithm. So before we go to naive-based algorithm, I just want to ask that whether audiences, is there any doubt or queries or question related to the KNN algorithm? If there are no questions, then I will proceed towards the naive-based algorithm. Thank you, Shivam. Thank you, Rishabh. Thank you, Shoma. Thank you, Tarun, for your precious feedback. As Sanjeev ji, it will be shared by the organizers. After this session, I will share it. So if you already have installed R, you can try out by seeing the screen as of now, or you may just follow the steps and you can reproduce the results later. Nothing to worry about it. Everything will be shared. So is there any query or question from the KNN side? It's now 4:55, so I will wait for 2 minutes. Okay, till 4:57. If there is no query, then I will move to the next part, that is naive Bayes algorithm. Okay. So please, if you have any query, please post it in the comment box, or you can, or otherwise we'll move to the next part of discussing the naive Bayes classification using R. So it is not possible to cover everything, but we will try to reproduce the results of few of the popular machine learning classifiers and see that how the systems are performing. Okay. So we have covered KNN so far. If you have any query, please put your query in the comment box. Otherwise, we'll move to the naive Bayes classification. EDA means exploratory data analysis. Okay. So exploratory data analysis is all about that whenever you are doing certain research. Okay. What is the main motto of the research? That you have some little information and you want to explore it in much more detail. So whenever you are starting in a new domain, you don't have the much knowledge about the what would be the data, how the data will behave. In every domain, we don't have the same type of the idea. If some domain, if you have a lot of data analysis has already explored, then it's fine. There are some very new domains where you don't have the much more explorations. Okay, you don't have much more idea. So if you are doing the analysis on those data, you are preparing the white papers or you are writing research papers, you are doing certain analysis, then it is a part of the exploratory data analysis, CDA. Okay. Thank you, Shivam ji. Thank you. Turns out email in but can good solution in English. Okay, so these are the not the questions related to the KNN. Okay, these are the very general question what you are asking. But still, I am telling you that the in every domain, whether it is agriculture, it is healthcare, in every domain you can use the machine learning. Okay, and none of the system is perfect. So if you're whenever you get the permission in the healthcare domain, especially it is the sensitive domain. But whenever you are exploring the machine learning algorithms in the healthcare domain, so you have to test the data. Okay, first of all, you have to collect the data, you have to write the IRB protocol with the doctor. So if the medical board gives you the permission by watching that your methodologies or whatever the use systems you are using that is non-invasive to human body, then they will give you the permission to make the trial. You will collect samples, then you will do the analysis. The medical board will review. For example, you want to come up with some app. It can be, for example, cancer detection app or the diabetic retinopathy detection app. So there will be the medical board. They will basically do the alpha testing. Okay, once the alpha testing phase your product get okay, then there will be beta testing phase. So in the beta testing phase, if your app passes, then only you will get to public launch permission. So remember that in healthcare domain or any other case sensitive domain, whenever you are coming up with AI based solutions, your solution is playing the role of catalyst. You are not the doctor. Okay, the doctor, or I am not the doctor. If you are the machine learning expert, you are trying to produce some methodology which may play a very, very positive catalyst role to help the doctors in their diagnosis task. That's it. Even if your app is giving the results 100% correctly, if the doctor feels that, okay, this particular patient needs to do biopsy, then he will refer that. Because you see, cancer biology varies from people to people. So it may happen that even if your app is predicting correctly that the person does not have cancer, the tissue is not cancerous, still doctor can recommend the biopsy if he feels or she feels so. Because it may happen that there are some the tissue is not malignant as of now, but after 5 or 10 years it may become malignant, because they have the experiences, they have learned the medical sciences for the 6 years during the 5 6 years during their MBA studies. That's the reason they are nowadays doctor. So nobody learns human body better than the doctor. So remember, whether it is healthcare or any other domain, always AI based tools are the catalyst. They are trying, the main role of the technology is that to become the blessings of the society. So we are trying to our level best by whatever the learning we have by analyzing the data. We want to give some positive outcome towards the society. Now, in every domain, they have the domain experts. These domain experts will decide whether to rely on this type of the predicted outcome or follow some other gold standard procedures. Okay, should I start with ML, have a good progress in it, and then move to DL, or I can directly start DL as it? You see, Nikita, like I mentioned, that the machine, definitely the deep learning is a hot cake nowadays. But you have to understand that if you don't learn, don't know the basics, nobody will offer you the job. Or whether if you even apply a PhD position in good institute for the higher studies also, then you will face the same problem, because people will often ask you the very basic questions. Because you see, deep learning is a learning those models, applying them at the nothing is there, because the main foundation is in the beginning. If you don't know, for example, if you ask, somebody is asking you that what is logistic regression, and if you can't answer that, there is no point of knowing deep learning, because that is not going to help you. Because if you can't answer the basic question, then people will lose the confidence on you. So what you have to do, you have to follow step by step. So first, make sure that you know the basics of the statistics correctly: descriptive statistics, inferential statistics, what is p-value, what is critical value, okay, what is your ANOVA, okay, this what is chi-square. These concepts, try to learn it. Then gradually explore it with the machine learning algorithms. Try to understand what are the shortcomings. Okay, first start with a very small data size. Okay, first to start deal with the small data sizes, then gradually explore it with the data of in order of 10 to the power 5, where the deep learning can be deployable. Whenever you find some data deficiency, then you may try out with the transfer learning to enhance data sizes, and then you may explore the deep learning. So in this way you may learn. Okay, so start right from the basics, learn the machine learning correctly, accurately, then gradually start with deep learning. Okay, I have seen many students, they are very brilliant students. They are writing great research papers. They somehow learned deep learning, they have applied it, their paper got accepted in good journals. But the problem is that whenever they're applying for jobs, they are not getting the job. What is the problem? Because they have skipped the basics. Whenever they are being asked very simple questions, that what is sigmoid function, they are unable to answer it. Why we are when to use machine learning, when to use deep learning, these concepts you require to know, because they have learned few of the methods, they only can tell it. Okay, so that is a very dangerous thing. Okay, try to understand that if you want to build your career in data science domain or the AI domain or machine learning domain, try to learn the nitty gritty of it. It is not very easy, trust me, because there are a lot of things are there. So make sure right from the beginning of your career, if you are interested in data science or machine learning or deep learning in this domain, you want to explore it. Right from the beginning, make sure that your statistical base, your base on linear algebra, your base on machine learning are very strong. Then gradually start to explore on deep learning. And any of the programming languages, it is better if you know both R or Python, but at least one of the R or Python you require to know. And you see, Python is a very versatile language, and in data science domain it has a lot of demand, because you see all the machine learning frameworks or the deep learning frameworks, these are the highly Pythonic, whether it is TensorFlow, PyTorch, Keras. Okay, so make sure that you know them very well. Okay, so in which area we work more on machine learning research or application? It depends upon the way you want to build your career. If you are planning to go for a high salary job, then try to do some project on real world data. It will showcase your efficacy, that you know that you can apply them, and then you have to crack the interviews. Okay, research, if you want to pursue for the higher studies, then definitely it is okay. Or in the if you are applying for the any R&D section, it can be research scientist position or it can be research engineer position, then your research skill will definitely going to help you. And if you want to do some launch some product, that is also fine. You may take patent, you may start your own venture startups, then it is also fine. A lot of people are doing that nowadays. If you see, either people are launching AI based products in the startup, or they are starting their own company for giving the training on AI and all those things. So in those cases also, so it depends upon the way you are planning your career. Okay, And for example, if even if you are doing not in the R&D section of the company, you may have to write the white papers. So that's the reason data interpretation becomes very, very important, because you have to compare with all the results. So that's the reason you require to know very different tools, very popular tools. You may have to compare some machine learning tools with deep learning tools, and what are the outcomes you are getting, why they are giving you the superior result, which results are acceptable or not. That type of things you have to explain. That's the reason I'm saying that go step by step. Okay, learn the basics and also make sure that you know the data structure very well. Okay, also clear. Thank you, Ritik. Thank you, Adrita Acha. Okay, thank you, Sisira Reddy. Okay, Jura Singh has asked one question: which other domain can I learn along with email or fits it using? Okay, so like you see that whenever you are learning machine learning, people are expecting that you will do advanced machine learning. That means you are covering the deep learning. Okay, and if you are interested in image processing, then you may cover up the computer vision portion as well. Okay, because that would be good to know, because a lot of deep learning applications are there in computer vision domain. Okay, you are already covering this signal processing as well. Signal processing, image processing, those are the relevant part. And if you are in case you are interested in quantum domain, you may cover up, like I mentioned, that you may learn quantum computation, and then you may explore quantum machine learning as well. That is also the future. You see, now it is 2022, and we don't have much time. By 2035, we must have to switch in the quantum machine learning domain, because the world will be quantum. Quantum is the future. Okay, so as of now, just focus on the basics. Okay, slow by slow. I mean, learn one by one thing. Okay, and then just try to explore it with on the basis of the project. It can be some real world project. Those who are interested in higher studies, they may explore in some research problem as well. That would be the helpful. Okay, remember the slow and steady wins the race. So try to make your grip strong, because this field is like ocean. Okay, it's not an easy field to explore on. It's not like, remember that it's not only about running few lines of code. You have to interpret them. Okay, and there are a lot of things are there. If you see the mathematical aspect, statistical aspect, many things are there. There can be several challenging problems can be there. It may happen that you are very strong in coding portion, but lacking in the math portion. Or if your math is very strong, you are lacking in the coding portion. So anything can happen to you. So don't be overconfident in this field. Okay, try to be a keen learner, because the field is expanding day by day. So make sure that your root are very strong. Acha, email based job. Okay, Abhishek has asked about the tips to find the email based jobs. You see that nowadays a lot of companies are now look, because today's world is a data driven world. So companies like Capgemini, they are looking for the people with data scientist. TCS Innovation Lab, you may find out they are also looking for the computer vision experts, data scientists. In computer vision expert, by default, they are considering that you know data, you know TensorFlow, deep learning as well. Where you have a strong grip on deep learning. Okay. Also, those who are from the management background, they have a lot of opportunity nowadays. They are, the opening for the business analytics position is there. In the business analytics position, earlier days, basically people used from the engineer, stat, or the economics background, people used to apply. But nowadays, the openings are coming up in for the MBA students as well. How much help will email give in mechanical domain? You see the system fault detection. Okay, so machinery fault detection purpose. A lot of uses are there in case of the in case of AI or email. A lot of people are using that. So in the machine performance detection, machine fault detection, all those things, you can find the lot of applications of AI enable. Even in the semiconductor industry, okay, if there is any fault in semiconductor devices, that can be predicted through AI ML. You see that It depends on the many cases, because if we are talking about healthcare domain, we will evaluate the model performances on the basis of the sensitivity, specificity. Okay, that's the reason we often go with this type of the confusion matrix. But in many domain, there are other domain also where if you look at the accuracy, that would be fine. So it depends on the domain basis. In healthcare domain, we mostly go with the specificity, sensitivity rather than going with the accuracy. Okay, so I believe that I have answered the all the questions whatever there in the portal. Now I think it is better to just discuss the naive-Bayes algorithm, because not much time left. Once I cover up the naive-Bayes algorithm, I will also share few of the other materials as well, which you may practice at your home. Okay, and I hope that in the near future I will again get opportunity to interact with you, and then I will explore with all of you on the quantum machine learning, because now all of you will have some idea. If you practice those materials at your home, you will have some strong grip on the machine learning. So then we will be in a perfect setup for explore in the quantum machine learning. If you guys want to do a session on the deep learning, then you can inform your organizers, so I can do it in near future as well. So as of now, let us start with the discussion on the naive-Bayes algorithm. So a naive-Bayes algorithm, like you may remember that I was telling you that it is better that if we have the strong grip on the probability. Why I was mentioning that? Because this type of the algorithm, like naive-Bayes algorithm, or it may have these scenarios like you are dealing with the hidden Markov model or Markov model. These are the dynamic Bayesian model. So in those cases, the fundamental strength on the basis of the knowledge you have and the conditional probability of the Bayes theorem, that will play a very, very important role. Now you see that it is quite understandable that naive-Bayes algorithm is completely based upon the Bayesian theorem. That's the reason the naming Bayes has come up. But why it is naive? The naive is used, the terminology is used because we are assuming that all purpose, they are independent of each other. So naive-Bayes classifier assumes that the presence of a particular feature in a class that is unrelated to the presence of any other feature. So for example, a fruit may be considered to be an apple, that if it is a red, should the shape of the fruit that can be round, okay, and what will be the dimension? 3 inch in diameter. So in this way, if you see the particular features, color, dimension, or the shape, all these are the independent of each other. So that's the reason. In those cases, there is a perfect platform to apply naive-Bayes algorithm, because we are dealing with the independent feature. Now, these naive-Bayes models are very easier to build, and there is very much effective for the large data set or the noisy data set. Because remember that any of the noisy data sets, whenever we are talking about, it is the perfect setup for applying the Bayesian type of the algorithm. So, for example, if you have all of you know the Bayes theorem general purpose, that the posterior probability for given x, okay, what will be the class? If you want to predict the class for a given x, this is the posterior probability. Now that will be equal to likelihood, okay, probability of x, probability of the predictor for a given class, into probability class prior probability of c, whole divided by probability of x, which is the predictor prior probability. Okay, so now you can predict the posterior probability of class when your attributes or the predictors are given. X is given, so what will be the probability of the class, or the attribute or the predictor is given there, what will be the probability of the class? So this is the basic structure of the Bayes theorem. Okay, now we will see that what will be the working methodology of the naive-Bayes algorithm. So there basically we will see that whether data set is given there, okay, and possibility of the play or non-play is there. So like I told you that our first target will be to explore the basics of the theory, then we will see one mathematical problem, and then we will explore it in R. So here we will first do the mathematical problem. So we will check that whether, depending upon the weather, whether there will be the possibility of the play or not. Okay, so what are the steps we have to perform? We have to convert the data set into a frequency table. Okay, then in the next step, we have to make a likelihood table. Okay, by finding the probability like the overcast probability or the probability of playing. Those things we will explore. So you see, weather and play informations are given there. From there, we will make the frequency table. So weather, what are the conditions? Overcast, rainy, sunny, and the possibility of the play, yes or no, we will check. For example, for the sunny weather, what are the possibilities of play? How many times yes are there? Three times. For the sunny weather, how many times no are there? Non-possibility of the play, two. For rainy weather, how many times possibility of the play yes is there? Two. How many times possibility of the play no is there? Three. For overcast cases, how many times possibility of the play is there? Yes, four. For the overcast condition, how many times possibility of the non-play? There is no information related to non-play. That's the reason we have kept it blank. So if you totally calculate it, how many times yes are there? 3 plus 2 plus 4, 9. And how many times no is there? 3 plus 2, 5. So grand total out of the 14 cases, 9 yes cases, possibility of play, and 5 no cases are there. Now, if you check the likelihood table, okay, so whether overcast, rainy, sunny, and yes and no, if you check, so possibility of the play 5 by 14, that will be non-play, that will be 0.36, and possibility of the play will be 9 by 14, that is 0.64. Okay, what is the probability of the overcast? 4 by 14, that is 0.29. What is the probability of the rainy? 5 by 14, that is 0.36. What is the probability of the sunny? 5 by 14, that is 0.36. Now, the problem statement is given like that players will play if the weather is sunny. Is this correct statement? So let us check that we can solve it using the posterior probability, basically using the Bayes theorem concept. So given sunny weather, what will be the probability of the possibility is? So that would be probability of sunny given by the possibility of the play into possibility of play yes divided by possibility of sunny weather. So we will put all those necessary values there, and we will find that the outcome of the possibility of the play yes, whether the when the weather condition is sunny, that is 0.60. That means it's a very much of the higher probability. So naive Bayes uses a similar method to predict the probability of the different classes on the basis of the different attributes, and it will predict the most likely outcome. Okay, so this is how you can solve a simple mathematical problem using the naive Bayes classifier algorithm and all those things. So the pros and cons, if you check out, that it is easy and very much fast for predicting the test data set, and it performs well on the multi-class classification purpose. And as I told you, that it is very good for dealing with the large amount of the data set. And whenever you are assuming that the independence among the features are there, the feature independency cases, it is very much effective to explore this type of the naive-based classifier. And it can also perform well in case of the categorical input in compared with the numerical variables. So in numerical variables, what happens that we always assume the normal distribution or the bell curve as a part of the strong assumption. Definitely, there are some con side is also there, that if the data has not seen the feature during the training period of time, then what will happen? Your probability, we will consider the probability is zero. For example, we want to predict a certain category. Now, during the training of the data set, that particular category was not existing. Then what will be the assigned probability to it during the testing as an outcome? It will be zero because the data has not seen that particular feature. So this type of the scenario is called the zero frequency scenario. Okay, and that can be overcome using the simplest smoothing technique like the Laplacian estimation. Okay, there are another limitations is also there, that in practical scenario it is not possible to get the all the independence feature. Okay, because there are some sort of the directly or indirectly dependency always comes up. So that type of scenario you may avoid as well. Application of the naive based algorithm, real time prediction purpose, multi-class classification or the text classification, sentiment classification, along with the collaborative filtering, naive based classifier are being used. Recommendation system is also, it is being used along with the collaborative filtering. So it has a lot of applications. Now for the R programming, if we want to apply this type of the naive based algorithm, we will explore it for the same type of the dataset. Okay, iris dataset, all of you know that there are Three species are available: Iris setosa, virginica, and versicolor, where you have the 50 samples for each species. So it will be 150 altogether. And there are four features are there: the sepal length, sepal width, petal length, petal width. Okay, four features are there, and one column will be for the species. During the prediction, we will omit this species column to remove the biasness from the system. So we'll follow the same steps. We'll upload the data because iris data is the inbuilt data in R. So you'll apply the data function over iris to load it. Then you will apply the str function to see the structure. So 150 observations of 5 variables will be there. Okay. Now what you have to do, you have to install certain packages to apply certain algorithm. So install.packages E1071 tools caret, all those packages has been installed. Then you are loading those packages using the library function. Okay, the once the loading is done, what will be the next step? It is the same thing like we have done for the KNN. That is a splitting data into train and test data. So what you will do, you will apply this sample.split function over iris dataset. Split ratio will be 0.7. Okay. Then what you will do, you will apply the subset function over iris dataset. First argument, split equals to true. We'll store the result under train underscore class. Similar process for the storing the data by applying the subset function to store the data under test underscore cl. Okay, iris dataset is the first argument. Split will be equals to false here. Now feature scaling. During the feature scaling section, during KNN algorithm, you have seen that we have omitted the fifth column present in the iris dataset. Okay, so same thing we are doing. Left side of the comma during the train underscore cl index will be, we have don't have to write anything because the row information will remain same. For the column, we are omitting the fifth column. That's the reason we are using first four columns. 1:4 will be there. Same thing repeated for the test class. Now, during the fitting with the name-based classifier, during the KNN, what we have done, we directly apply KNN function. But here, we have to do the randomization first. So do the randomization set.seed will be used because we want to pick up the maximum likelihood outcome. So randomization have to do. So set.seed, here we have written 120, you may do 123, 742, anything you may do. So whatever the value you use, the seed value will give there. According to the setting of seed, it will give the randomized outcome in R. Okay, then you use the name-based function. Now remember that I told you that R is a case-sensitive language. So whenever you are writing name-based function, make sure the B will be in capital letter of the name-base. Then species is the outcome you want to predict. Tilde sign. Right side of the tilde, you don't have to write anything. Only full stop will be fine. Because on the basis of the sepal length, sepal width, petal width, you want to predict the species. So that's the reason you are not writing anything, but you can also write it as well. Sepal length plus sepal width plus petal length plus petal width. In this way also you can write it. Then comma, the second argument will be data equals to train underscore cl, and then you are printing the classifier underscore cl. So once you are printing it, you will get the following type of outcome. Okay, where you will get the priority probability information, conditional probability information, all those things will be printed there. Okay, so now once you have printed the conditional probability for each of the feature or the variable is created by using this type of model separately. So the a priori probability can be calculated here. How can you do that? Simply use the predict function over the first argument classifier underscore cl. Second argument will be new data equals to test underscore cl. Now you form the confusion matrix. You know in R how to form the confusion matrix. You will apply table function. Then in the first argument, test underscore cl, there will be the species column. Then y underscore predict. Now once you print it, you see this type of the table you will get. Confusion matrix you will get where 20 setosa has been correctly classified as setosa. Out of the 20, versicolor has been 20 classified correctly. Out of the 20, virginica 17 has been classified correctly. 3 has been wrongly classified as versicolor. Okay. Now how can you do the model evaluation? So once you apply this confusion matrix function over it, you see the accuracy is 0.95 has been given there. There are other information related to kappa and all those are there, but output you got, that is the 0.95. Okay, so that means this is a very good outcome. Also sensitivity, specificity, all those informations are given there. So that's the reason you see, due to the higher accuracy, name-based classifier used largely for the sentiment analysis, document categorization, emails filtering, all those things. Now you see, as the output you will get lot of interesting things, okay, which you require to know. That's the reason in the special notes section I have mentioned them. Like, for example, what is kappa in confusion matrix? Now, the kappa coefficient will give you the argument between the classification and the truth value. Whenever you have the value near 1, that is the perfect argument. 0 means no agreement. What is the value in kappa we got here? Apart from the 95% accuracy, the kappa value is 0.925. That means 92.5%, which is a very good kappa value. Kappa value nearby 1 means your system argument is highly appreciated. What is no information rate? No information rate is the largest proportion of the observed classes. Okay. So a hypothesis test will compute and evaluate whether the overall accuracy rate is greater than the rate of largest class or not. So here you see no information rate NIR. If you see here, basically the accuracy is greater than NIR. Okay, that means our result is acceptable. Always remember that overall system accuracy should be greater than the accuracy of the largest class. So here you can find that. So that is the no information rate. McNeema test. Okay, so McNeema test is basically a statistical test which can be performed on a nominal data. So basically 2 cross 2, the contingency table will be there for the dichotomous or the binary classification purpose. Okay. Now the balanced accuracy, what does it mean by the balanced accuracy? So is a one kind of accuracy. You will check that how good a system can do the binary classification. Okay, or it is basically useful for the whenever you have the imbalance of the class. That means one of the two classes, whenever you are dealing with the dichotomous cases, binary cases, if one of the classes are appearing often than the other, so these are the imbalanced class. So in those cases, the balance accuracy is very much important. So anomaly detection purpose, presence of diseases in healthcare segment, this type of the balanced accuracy is being used. So here you see the balanced accuracy for the Setosa 100%, Versicolor 93.48%, Virginica 96.51%. So it is very much effective that the while calculating the balanced accuracy, it is very very important to check that whether you very much effective for the imbalanced data set. Now the confusion matrix, it will form a table to check the performances of the test data. So there are few terminologies are related to the confusion matrix, like the true positive cases. So these are the cases in which we predicted yes when they have the disease, and they do have the disease. So these are the true positive case. What is a true negative case? You predicted no, but they don't have the disease. What is the false positive case? You predicted yes, but they don't actually have the disease. So this false positive case is a type 1 error. What is the false negative case? You predicted no, but they actually do have the disease. So this is a type 2 error. So how can you calculate the recall from there? Recall sensitivity or true positive rate all are same. So that would be true positive divided by true positive plus false negative. What is the specificity? This is a true negative rate. True negative whole divided by true negative plus false positive. What is the balance accuracy? Balance accuracy will be sensitivity plus specificity whole divided by 2. What is the detection prevalence? It can be determined with the number of the predicted positive events. Okay, so both true positive and false positive divided by total number of predictions. What is the prevalence case? It can be defined by the number of the actual positive events so divided by the total number of the predictions. So you can check that all these calculated values are given there. You got it during the after running of the code. You see detection prevalence, detection rate, prevalence, negative predicted value, positive predicted value, specificity, sensitivity, all those outcomes you got here. And that's the reason I have mentioned all the definitions of the outcome so that you can understand, you can make the interpretation of the outcome correctly. So what will be the detection rate? The prevalence will be the number of the positive, actual positive events whole divided by the total number of the prediction. That is the prevalence. And that is the detection prevalence is the number of the positive cases whole divided by the total number of the predictions. Detection rate means D whole divided by 2 by N, T by N. T is the true positive result and N is the total number of the patients. What is the positive predictive value? It is the probability of the subject with the positive screen test truly have the disease. What is the negative predicted value? That would be the probability of the subjects with a negative screening test when you don't have the diseases. So this type of the things you will be able to see whenever and reproduce the results whenever you will go through this particular class note. So is there any doubt related to the naive-based classification?
Okay, so yeah, thank you so much, sir. That was quite a wonderful insight into ML world. It has
Okay.
been definitely sparked curiosity in the minds of our audience. So let us begin with the Q&A session now. And if you guys have any question, just post it in the chat box, and I'll just read it aloud.
So, due to the request of the several student, I recently started to write the Medium article as well. Okay, so I have already shared my Medium article link. I am requesting the organizers to share with all of you, because there you will get the career guidance. So you can follow me in the Medium. Okay, so there you can see I have written articles on how you can build your career in reinforcement learning. Okay, what are the impacts of our AIML in our daily life? So in this way, robotic process automation. So all those state of art topics has been shared there. Also, I am sharing my all the workshop videos in my own YouTube channel, so you can subscribe them as well, in case it may be helpful for you guys. So I am sharing in the chat box section, so already posted there, so requesting the organizers to share with all of you. So there you will get a lot of hands-on session there. I have executed for the machine learning, deep learning cases. You may subscribe my YouTube channel as well, and you can follow them. And I am writing my email ID in case you require some guidances from me related to the AIML part. Okay, so you can contact me anytime if you require any help. Okay, so you can also contact me anytime whenever you require to contact me. Also, the GitHub, I am gradually started the tutorial for the students to guide them in the GitHub. Okay, so I am building the GitHub repositories, a separate repository. This is the separate account I made for the only for to help the students. So I'm gradually loading a lot of contents. Okay, so students may follow me GitHub as well. This is only for the students or the other ML enthusiastic, those who are want to explore their career in this direction, so they may follow it. Okay, already I have mentioned they answer this similar question, that module accuracy and model performances. You see, like I told you, that model performances you may prefer, like sensitivity, specificity, whenever you are dealing with the healthcare data. There are several segments like the healthcare where we prefer more on the rely on the sensitivity or the specificity rather on the model accuracy. But there are other segments where the only the model accuracy can do the job. Okay, depends upon the data you are dealing with. You can't deal the every data in a similar manner. Okay, there are according to the data, the system performance will change. For example, you are doing the star detection. Now, if you are doing the star detection, you know that there will be the chances of the saltpeter noise. Okay, so you have to apply the median filtering during the pre-processing purpose to remove the saltpeter noise, and then you may process the star detection purpose. So domain wise it will change. Like you are doing some optical experiment in the those people who are from the biophotonics background or the physics background, they may know that there are chances due to the laser using of the laser, there will be the granular noise, presence of the granular noise will be in the system. So you have to remove them first in the data pre-processing purpose, otherwise your prediction will not be perfect. So whatever the elegant algorithm you may use, your data pre-processing should be very robust. Okay, because domain wise the system performance will change. Okay, so it will not be the same thing like the way you will measure the using anemometer, the wind speed data set. You can't deal the same thing for the biomedical images. So depending on the data, you have to plan of that what would be my expected outcome, what are the theoretical outcome, what are the observed outcome, whether my model is perfect, doing well or not. So accordingly, you have to plan of, okay, you may have to remove the noise, you may have to do the background extraction. So all those things you may do. Like, let me tell you, those are from the signal processing background, students may know that in general we consider that noises are in additive format. In general we call them sometimes as the additive white Gaussian noise or all those things. But those who are from the telecommunication industry, they know that there are and one type of noise that is called fading. Okay, like due to the presence of the large building, and if you are doing a phone call, you get fading effect, and that type of noise is being comes in the multiplicative format with the signal. So domain basis your data will change, and you have to do the proper treatment with the data. So the more you will deal with the data processing, the more you will learn, and then you yourself can make the proper judgment. That's the reason I'm saying that you have to devote yourself in this domain to get a masterpiece on it.
Thank you, sir. So
Thank
let's
you.
move on to the next question. Ritik asked that how to build up a system which continuously learn from the new data so that it can adapt with the changing trends in data.
You can apply reinforcement learning, like I mentioned. That is a very good question, and that is the future actually. You explore reinforcement learning, you will get it. And if you have any doubt or any queries, feel free to ask me. And in my GitHub, you will get some code related to reinforcement learning. Explore my GitHub. Okay, that's the reason I shared my GitHub link. You guys can follow that, and you will get the guidances. And my email ID already shared in the chat box. feel free to question me up there.
Yes, sir.
Okay, so
Moving on
Priyanshi
to,
has one question.
yeah,
Is
so
it
Priyanshi
possible
asked
to
a
test
question. Yeah.
without cross validation technique? Look, cross validation you may do, you may not do, but in case of these several methods, like for example the support vector machine or all those things, we generally goes with the cross validation. It is better to follow the cross validation. Okay, it is always preferable if you do the cross validation. That is desired until and unless you are coming up with so much robust techniques. In general machine learning practice, it is better to go with the robust cross validation approach.
Thank you, sir.
Arjun, which other
Arjun.
domains can I learn with email? If it will, like I already answered this question, so you can write it down now. Okay, otherwise you will forget again. So you may explore, like I told you, that students, those who are interested in image processing or the video processing, so they may go through computer vision. A lot of computer vision related jobs are required the background knowledge of deep learning as well. So there you may explore a lot of deep learning skills in computer vision related stuffs. Okay, uh, you may, those who are planning of their career in the business analytics domain, they may learn the subjects like the business forecasting. In those cases, you may have to go through arma model. That means that you have to make your strong basis very strong in statistics and advanced statistics. Okay, and there are other also the areas are there which you may explore along with the machine learning, depends on your interest. Like if you are planning your career in the quantum machine learning domain as well, so first of all you have to have a very strong grip in machine learning. Then you have to know the quantum computation, and the basic things will remain same: statistics, probability, and linear algebra. All those things will be there. You may explore in quantum machine learning direction as well. So there are the possibilities that in which way you are planning your career. If you want to plan your career as a computer vision scientist, you may go around that. You can explore in image processing, video processing directions. If you are planning of the quantum machine learning, you may plan of your career on that direction as well. If you are planning to build your career in business analytics, then it will be always good to have some idea on the business forecasting techniques, data visualization tools for managers. Okay, in those cases, it is always desirable that if you know the advanced Excel very well, along with the all those preferred techniques and methods which I mentioned during the beginning of our discussion. Okay,
So
so
the
those
next
things you can
question
explore.
is,
I have here two different things.
yeah,
ML, you
sites.
must know maths before ML. You can do ML without who. Why is that? I do not know who has said you that you can do ML without knowing math. Okay, nobody is telling you to be the highly efficient in mathematics like the math honors students will do, but basics of mathematics is always required. Okay, you can run the codes blindly by not knowing anything and you can get the outcome. That is fine. But as I told you, you may even get the research papers outcome it as well. But as I told you, that during the job, forget about the company job. Even in the teaching job, whenever people will ask you basics, you will not be able to answer it. So forget about company job, forget about PhD, all those things. Even if you simply apply for the teaching with your master's degree, which is the minimum mandatory nowadays, from 2023, PhD will become mandatory for the teaching profession as well. Even if you are applying that, you will not get the job if you don't know the basics, because people will ask you very basic question: what is they may ask you the question, what is PCA? Once you tell them what is PCA, then they will ask you that what is eigenvalue, eigenvector. If you can't answer them, people will not accept you. So right from the beginning, I am telling you that basics, nobody is telling you to be the masterpiece in mathematics, but at least basics of the math, linear algebra. Okay, how to do matrix multiplication, what is determinant, what is eigenvalue, what is eigenvector. Those things are desirable from you guys to know that. What is Bayes theorem from the probability sector? These questions are the very basic questions, and if you can't answer them, then there will be the serious problem if you are planning your career in machine learning directions. I know you guys are smart enough to understand that, and you will definitely do well in your career. But as you are asking me, I am just telling you honestly, to such that all of you can excel in your career. You guys should not be misguided. Okay, you have to know the reality, right? That is the motto of this type of the sessions. Okay, so how can you collect the large amount of data as a student? Okay, so you can collect data from the GitHub. Okay, there are a lot of interesting projects are there. You can download the data from there. You can collect data from Kaggle. If you are planning to build the product, so for the initial validation of your model, you can do explore the data from GitHub Kaggle, but then you have to connect with the corresponding industry, because in real world data there we will find a lot of noises, presence of noises. And if you are planning a building product with your AI/ML applications, you have must have the real world data, especially in the healthcare domain. Okay, then you may approach to hospitals with your instruments or the whatever the methods you are following, that our method is completely non-invasive, or whatever the instrument we are planning to collect the data, that is non-invasive. So please give us the permission to do the medical trial in the hospital. So if you can convince the doctors, they may allow you. And for that reason, you may have to show them some of the promising outcome which you have got by exploring the GitHub datasets or the Kaggle datasets. They may, if they are convinced, they may allow you to do the necessary trials. Okay, so domain basis, it depends. But as I told you that if you are planning of the product development, then you have to, first of all, you have to validate your results with the Kaggle and GitHub resources, then apply to the corresponding industry. And for the academic research or in other cases, it is fine to do the analysis and publish papers from the GitHub or the Kaggle resources. There is no problem. Okay. Thank you very much,
Okay. Thank you,
Mahidhar, for
sir.
your precious feedback. Thank you, Kosta.
Thank you, sir. It was a really informative Q&A
Thank you
session.
very much.
Also, because of the time constraint, we won't be able to take any further questions. Apologies on our behalf. Now, I think I have reached the culmination of today's workshop. And once again, I would like to thank you, sir, for imparting your knowledge and taking out time for all of us. Thank you so much, sir.
So thank you very much to all of you for inviting me here. It's a really pleasure to interact with all the young minds, and I am very much thankful to the organizers for taking the pain to do this kind of workshop virtually so brilliantly. So kudos to VIT IET team as well. Okay,
Thank you, sir.
and all the students, those who have participated and shared their precious times with me. So thank you very much. Take care.
Thank you, sir. Thank you,
Thank
sir.
you. Thanks a lot.
Thank you.
Thank you.
Thank you so much, sir.